Hi, this is Evans from Crazy Chemistry. In the previous video, we saw what defines rare earths. In this video, we're going to see how we can extract them. If 1 plus 1 equals 2 and 2 plus 2 equals 4, what is the square root of pi divided by 195,867? Some people might find it hard to do this without a calculator, while some other people might find it impossible. The point is that in order for you to solve it, you need the right tool. Same with the rare earth. Finding them is easy, but separating them is the hard part. Let's say we're in a mine, we are standing on top of a rare earth ore. We are all happy, all excited. Now what? Are we rich yet? Sadly no, we need to work for it. As we said in episode 2, we don't magically find concentrations of rare earth metals underground. They're embedded in rocks and minerals. Some of the minerals are called bastnäsite, monazite, and xenotime. For first step, we need to mine the ore out of the earth. A typical low-grade rare earth oxide ore contains 1 to 3% rare earth oxide. A good grade would contain 5 to 10% rare earth oxide, and a very good grade would contain above 10%. And let's say we mine the ore and we have it. Now what do? First of all, we need to crush it. In order for us to be able to access all the rare earth, imagine it like a piggy bank that you want the coins, so you need to break it in order for you to be able to access the coin. So we crush it into small pieces, and now what? Now we have waste material and our rare earth minerals, and we need to separate them from each other, right? Because they're all mixed together. So how do we do that? There are three main techniques that we can use to do that. One is called froth flotation. We get the crushed ore, we add it in a tank with water and chemicals, and we inject bubbles, and the bubbles take the hydrophobic minerals on the surface as a froth that later on we can keep it off, and then all the wasted material stays at the bottom. Another technique is called gravity separation. The crushed material is introduced in a medium which is either water or air. Under the force of gravity, heavier particles settle at the bottom, while lighter particles are carried away. The third technique is called magnetic separation, and in this technique we just use a magnet in order to separate the non-magnetic material from the magnetic material. Using these techniques, we can upgrade our concentration from 3% to up to 30 to 70% of rare earth oxide. But we need to improve further, right? For example, if you ask me for a red marker, I cannot give you a purple marker and say, my red marker has a little bit of blue inside, I'm sorry. No, it needs to be red. So we need to improve the concentration even more. How do we do that, right? We get the 30 to 70% concentrate and we add it in sulfuric acid or hydrochloric acid, or we do some alkaline breaking with sodium hydroxide or potassium hydroxide. So we dissolve everything and we create a soup which consists of rare earth ions. Rare earth elements, they form 3 plus ions after they lose their 2 outermost electrons and 1 electron from 4f or 5d orbital. This way they form a more stable lower energy electron configuration, like we saw in episode 3. In this soup, all rare earth ions are mixed together, and now the hard part begins. Rare earth elements are chemically very similar. The ionic radius differs only very slightly, and that makes them very hard to separate. So we use a technique that we call solvent extraction. So we have 2 liquids. One is the acidic aqueous solution which contains the rare earth ions, and the other is a solution that contains organic extractant molecules. The separation works through 3 main stages. In the first stage, we get the ion soup that contains the acidic aqueous solution with the ions, and then we mix it with a different solution which contains organic phase extractants such as P507 and D2PHPA, diluted in kerosene. The extractant molecules selectively bind with some specific ion in this soup, and they form a metal-organic complex that contains the organic extractors and the rare earth ion. In the second stage, we get the loaded organic extractors and we wash them with diluted acid to remove all the unwanted impurities and lighter rare earth elements that they were co-extracted, in order for us to be able to achieve a higher purity of our target rare earth element. Then in the third step, we transfer the desired rare earth back to a new clean aqueous solution that contains a stronger acid, higher concentration of hydrochloric acid for example. So we keep repeating these three steps over and over and over hundreds of times, and gradually we achieve a better concentration of a targeted rare earth element. This is why the rare earth separation plants are so massive, and infrastructure matters more than mining. 90% of the refining capacity takes place in China at the moment. After we achieve a satisfactory separation of rare earth ion from the soup of rare earth ions, it's still in a liquid form. We need to collect it as a solid, right? We need to precipitate it at the bottom in the form of an oxalate or a carbonate. After this step, we heat it up to 1000 degrees in order to turn it into its oxide form, which is easy to transport. Then in the future, if we need to use the rare earth in its metal form, we will have to reduce the oxide through calciothermic reductions or molten salts in a cell. Another method that we can extract rare earth elements is through recycling, but this we will see it in a different video. So that's it for today. Thank you for watching. In the coming videos, we're going to start looking each rare earth element individually. If you like the video, please consider liking, subscribing, leaving a comment, sharing the video. I'll see you next time. Bye!